Yes, I am here.
Okay.
I'm going to share my slides. Just a minute. Hope you can see my slides on the other side also.
Yes, we can see it clearly.
Okay. Assalamu alaikum. Hello everyone. My name is Rida Miraj. Today I am going to present my paper, which is about humor detection using a bidirectional encoder representation from transformer-based neural ensemble model. The first author of this paper is Rida Miraj, and the second author is Masaki Aono. So let's start. I'm going to follow this outline. First, I will introduce what kind of project I did. So, and which will be followed by the research challenges. And then I will discuss about proposed methodology. And in the end, I will conclude and give some future direction. So my main topic is about humor. So the first question that comes in our mind is, what is humor? And humor is actually the tendency of experiences to provoke laughter and provide amusement. You can see the example here. Here is the example. Did you hear about the guy who got hit in the head with a can of soda? He was lucky it was a soft drink. So you can see in this sentence, so we can find humorous thing just because of word soft. So this is all I'm going to detect in my next slides. So my topic is related to humor detection, for which I have to build a system which can rate humorous effect that is caused by small changes in text. When I use the word small changes, it's mean in the sentence I will change one word in the whole sentence and check now how much humorous this sentence is. And the data that I used for this task was taken from the Reddit website. And here is an example. In the first sentence, there is written a headline, which is "4 arrested in Sydney race to stop terrorist attack." And this word attack has to be changed with the word kangaroo. And now we have a new statement, which is "4 arrested race to stop terrorist kangaroo." And now our task is to detect the level of funniness in our new sentence. So this is we are going to do in our um, proposed method to detect the level of humorous. We want to do humorous effect evaluation with atomic change. The previous work that is already done is mostly based on humor detection in a sentence, whether a sentence is humorous or not. But now we are going to estimate the level of humor in a sentence, and it varies with the sentence structure also. Our mostly the humor kind of application can be seen in Madlib's kind of games, in which one word is changed and the whole sentence has a different meaning. So this is related to it. And what kind of research challenges I faces is discussed here. So one thing which comes in our mind when we think about humor is that what makes us laugh. So it can be the person facial expression or the style of conveying joke or body gesture, or it can be some irrelevant or some thing which is on the point of the situation. But in the research field, the exact answer is still uncertain. So this is our big challenge. And also there are some other challenges which include cultural effect. Mostly humor varies with the person to person and also area to area. It's hard for others to understand the sentence or thing which I find humorous. Maybe others don't find it funny at all. So this is the big challenge in this research part. And the other thing is, it's very difficult even for human to detect humorous and sarcastic level. Sometimes we also mix these two things, and for a model, it is a very crucial part, and it's hard to separate these two of them and say is this sentence is humorous or this is sarcastic is still very difficult. And the other thing is our data is mostly consist of short length of sentences, and which makes it more difficult, because to understand humor in a sentence, we have to be some information behind it, so that a person or a model can find it humor. But in this case, we have to use short sentences, and this is why
Hello? Do we lost Rida? Or is it me? Oh, probably the poor connection. Rida is currently freezing. I probably would love to invite, meanwhile, while we are waiting for Rida to come back to us, probably there are already some questions from the audience. Oh, I haven't turned on my video. Okay. So can the committee, what should we do? Shall we conclude the session or shall we wait for Rida? I am waiting for the instruction from the committee.
Perhaps we can do the certification
Okay, all
in
right.
the order. Yeah.
Okay,
Okay, I will share screen.
yes, please.
Excuse
Oh,
me,
wait.
I'm really sorry, I just disconnected.
Oh, okay.
Okay, Rida is back.
Okay,
So
okay, okay.
we have her again. I think we can continue with, can we
Okay.
postpone the certificate? Sorry. I think we can let Rida finish her presentation
Yes,
first, and then
yes.
we can take a picture of this certificate. Okay, thank you. Sorry. Rida,
I'm
welcome back.
I'm really sorry for that. It's just
That's fine. That's
okay.
fine.
So,
It happens all the time. Okay, you can continue your presentation.
I am discussing about the proposed methodology for this method, which is actually based on BERT model. And here there is a sentence which is going to be sent in the BERT base model. And then after fine tuning, we get a sentence with some other tokens, CLS token and SCP tokens. This is actually the classification and separation token, which are usually the requirement for BERT model. And this token actually updated with the each layer with when they are sent to transformer layers, and they updated with some weights. So in the end, we just use a CLS token which has all the information for in accordance with the sentence structure, and we use it as a feature vector. On the left side, we use a traditional way of embedding like fasttext, glob, word2vec, and combine it to get a embedding matrix, and then we send it to the multi-kernel CNN model, which from which we get also a feature vector, which then concatenate and then give us some prediction for our sentence. So this model has very beneficial effect than the using BERT alone. So there is some first let me discuss about BERT. BERT is actually the bidirectional encoder representations from transformer, which actually the stack of different transformer with which contains self-attention layer. There are two different sizes of BERT base and BERT large. In our model, we use BERT base to make it more easy to use, because BERT large it has some memory issue if we're going to use it. So for training data, we have less than 10,000 news headlines for training. And for validation, we have 2,419 news headline. And actually, these all headlines are labeled in the range of 0 to 3. It's a regression type problem, and they are labeled like it's the lowest funniness level is 0. If it's most funny, that sentence will be labeled with 3. So this is the data set, and we set some matrices parameters here, and there we use maximum length of our sentence, which we set was 40, and kernel size, we use 3 different kernel size, 2, 3, and 4, and number of filter was 36, and with 25 epochs we train our model on it, and with the batch size of 32 with the optimizer of Adam. And this is the parameter setting which we did for the proposed methodology. Here's some result. The proposed method which I just discussed give us the root mean square error 51%. Root mean square error is actually used for the evaluation purpose in our task, and it's good if it's lowest. So in our case, in comparison with the other experiments, our proposed methodology give us lowest root mean square error, which is way better than others. And this is some other experiments which I did with Robota, BERT base alone, and some basic neural network like by LSTM or by GRU. I conducted a lot of experiment, but our proposed methodology gave us best so far. And it's actually this whole task was a part of a competition, Samuel 2020. And I also here mentioned some of the top 3 teams results, and where the first team, Hitachi, has 59% root mean square error, and they also use the BERT with some other configurations. So, but our model is on second now, which is way much better. And this is the successful example I quoted here. The actual sentence here is Trump to make text speeches Wednesday, which is the word make has to be changed with the word sing, and now it's Trump to sing text speeches Wednesday. So our ground value was 1.4 for this sentence, edited sentence. When we use our proposed method and try to predict the value, it's give very similar to this one. And our proposed method is like 50-50, like 50% is okay and 50% is not, but this is a big gap which we filled, because to detect humor is really challenging in a sentence. So here I am going to conclude. So after doing this experiment, this was clear that cultural effect make this task more difficult, but there are a lot of aspects we try to include in it so that it can be easy to get some kind of good success in this field. And yes, we have some good results so far. We are trying to make it more better if we can work on some kind of sarcasm, irony, and puns. And if we have a background knowledge about all of these fields, it will be much better for us to understand humor much better. So this is all I did in this paper. So thank you. Is there any question? Is there any question? Am I still connecting with you guys?
Oh, I'm still muting my voice, sorry. Okay, are there any questions from the audience? I've been talking and I'm talking on mute. I'm really sorry about that. It happens all the time as well. I don't find any question from the chat room, but I do find it interesting that people are using BERT for literally anything, everything. I personally use it for object detection for development of car, smart car, okay? Because we need to detect what's in front of our car. Is it a cat? Is it a human? Is it a pole or something? Oh, there's one question from Arung. So I would like to read the question for you, Rida. So as humor is mainly subjective to each person, is there any standard used to determine whether a sentence is humorous or not?
Mostly there is not such standard, but so far mostly humor work is done on the English sentences, which is mostly that region of like US or European side. And in our case, when I am working here in Japan and discussing it with my some supervisor or some friends, they don't find it funny. So for this task, their standard was maybe you can say the other side, so US side. So there is no such standard. So for every language has their own. So yeah.
Yeah, I think that there are many, parameters, right? We have language, we have differences in language spoken, in the way we write. Probably we talk the same language, let's say English, but not everyone is a native of English, and not everyone is, not everyone understand, the humor there. So I got it. It's very challenging field and topics. I think